A system of linear equations is a set of two or more linear equations. Typically, when we're looking at systems, we're looking at we have two variables and we have two equations to solve for those variables. And the solution to a system is the point where the two lines intersect. So one of the ways we can solve a system of equations is by graphing. So for instance, if we graph the equation y equals 2x minus 1, have a slope of 2 and a y-intercept of negative 1. And it looks like that. And then if we graph the equation y equals 3x, so this has a slope of, or y-intercept of 0 and a slope of 3. And it looks like this. And we can see right here, the solution to this system is negative 1, negative 3. Obviously, the graphing method is prone to some human error, but if you graph in a program like Desmos and you click, you would actually just be able to see right there that they intersect. And in this one, for instance, so we have x minus 3, slope of 1, y-intercept of negative 3. And x plus 1, slope of 1, y-intercept of 1. So in this one, the lines are parallel. So this system has no solution. We have parallel lines, which never intersect. And we know the lines are parallel from the equation because they have the same slope and different y-intercepts. So like I said earlier, obviously solving by graphing is sometimes inaccurate and not always available. So one way to solve algebraically is through this method of substitution. And what we're going to do when we solve by substitution is solve for one variable, or rather isolate one variable. So solve for one variable. Variable. And substitute into the other equation. So what that looks like is right here we have x plus y equals 12. And I'm going to, it doesn't matter which, but I'm going to subtract y from both sides. Now I have x equals 12 minus y. And then I'm going to take this, x equals 12 minus y, and I'm going to substitute it into my second equation in place of x. And what that does is it gets rid of a variable for me. So now I'm going to have an equation that only has one variable. So now I have 3 times 12 minus y minus 2y equals 1, which is now an equation with one variable that's easy to solve. So I get 36 minus 3y minus 2y equals 1, which is then 36 minus 5y equals 1, negative 5y equals negative 35, and y equals 7. So now that I've solved for y, I'm still not done, but I can take y equals 7. And remember, right up here, I solved for x in terms of y. So I know that x equals 12 minus 7, which is 5. So the solution to this system is 5 is the point 5, 7. That's where those two lines are going to intersect. So this one we have a slightly messier example with these large coefficients. But the same idea is going to apply. So let's take this first equation, x minus y equals -1. And the reason I want to use the first equation to, in this one, solve for x, so I have x equals y minus 1. The reason I would use the first equation is this second equation has these really large coefficients. The first one, my coefficients are 1, so solving for x only took one step. So now I take y minus 1, and I'm going to substitute it in there in place of x. So I have 15 times y minus 1 minus 22y equals -29. So 15y minus 15 minus 22y equals -29. This comes out to -7y minus 15 equals -29. And then -7y equals -14, and y equals 2. And then we just have to go back and plug in y equals 2 here. So x equals 2 minus 1, which is 1. So the solution to this system is 2, 1. The point 2, 1. So that's where the two lines are going to intersect. So the substitution method is useful, but it can get pretty ugly if we had coefficients on the other equation as well. So another method we use is called elimination. And of course, our first example doesn't have coefficients on all the variables. The way elimination works is we're going to take one of the equations and multiply it by something, and then add the two equations together. So watch what this looks like. So we have 2x plus 2y equals 10 and x minus y equals 11. I'm going to take the second equation, and I'm going to multiply everything by 2. So now my two equations are, I'm going to rewrite the first one, 2x plus 2y equals 10. And the next one is now 2x minus 2y equals 22. And now I'm going to add both equations together. Which is just going to look, I'm going to combine like terms. And I'm allowed to do this from an algebraic standpoint because I'm adding the same thing to both sides, because these things equal each other. So on the left side I'm adding 2x and 2y, or 2x minus 2y. The right side I'm adding 22, but our equation says 2x minus 2y is equal to 22. So I add 2x and 2x, and I get 4x. I add 2y minus 2y, and those go to 0. That's why I multiplied by 2 in the first place. And 10 plus 22 is 32. And now we have a really easy equation where we can solve for x. So x is 8. And then, just as if you were solving by elimination or by substitution, you're going to take 8 and plug it into either one of these equations. The bottom one is nicer, so now we have 8 minus y equals 11. So negative y is 3, and y equals negative 3. Whoops. Sorry, so that was negative y equals 8 minus y equals 11, and negative y equals 3, so y equals negative 3. So our solution is 8, negative 3. So in example 2 here, there's nothing I could multiply. The goal here is to multiply by something that makes one of our variables the same in both equations. But here, there's nothing I can multiply 3 by to get 5, or 3 by to get 4. And it first helps, let's rewrite our equation in sort of in order. So we have negative 3x plus 3y equals 12, 5x plus 4y equals 25. So if you're super comfortable with fractions, you could, of course, multiply the top equation by 4/3, and then that would give you a negative 4x, or that would give you a 4y here. But most of the time it's easier, we're just going to multiply both equations. So suppose I want the x terms to cancel out. So rather than trying to multiply 3 by 5/3 to make it 5, I'm just going to multiply both equations. So I'm going to multiply the top one by 5 and the bottom one by 3. And that's going to make the x's both negative. It's going to make one of the x's positive 15 and the other one negative 15. So now I have negative 15x plus 15y equals 60, and positive 15x plus 12y equals 75. And now, when I add the two equations together, my x terms go to 0, and my y terms add to, I get 27y equals 135, and dividing both sides by 27 gives us y equals 5. And again, from here, since we got the value of y, we just have to substitute it into either one of these equations. I'm going to pick the bottom one because it has a positive x value, but it doesn't matter. You will get the same answer. So 5x plus 4 times 5 equals 25. So that's 5x plus 20 equals 25. 5x equals 5. X equals 1. So our solution is the point 1, 5. So lastly, we're going to look at two special cases of systems of equations and then a word problem. So in this one, so first of all, this is a good one for elimination because we have x plus y equals 11 and 2x plus 2y equals 10. So we can see right away, if you multiply the bottom equation by negative 2, because we want a negative x and a positive x, then our 2x plus 2y equals 10, negative 2x minus 2y equals negative 22. But if we add these two equations together, we notice that everything cancels out. So 10 plus negative 22 equals negative 12, I think. 2x minus 2x is 0. 2y minus 2y is 0. So we've reached the statement 0 equals negative 12, which I believe is false. And what that means is that this system has no solution. So it's just like the one on the second example we looked at. If we graph these two lines, these are parallel lines. And then, so anytime you reach a false statement, that means you have no solution. And this example here, it's almost the same problem. Again, if we multiply this bottom equation by negative 2, now we have 2x plus 2y equals 10. Negative 2x minus 2y equals negative 10. And when you know it, everything on the left side adds to 0. Everything on the right side adds to 0. So 0 equals 0. This is similar to the last one because all of the variables on both sides were eliminated, but different because now the statement we reached is true. So this has infinite solutions. And what that means is that these two are actually the same line. And if you graph these on Desmos, 2x plus 2y equals 10, and x plus y equals 5, notice the purple line gets put right on top of the green line. So they're exactly the same line. All right, and then lastly, a word problem. So a test has 20 questions, and the test is worth 100 points total. We have true-false questions that are worth 3 points, and we have multiple choice questions worth 11 points. And we want to know how many of each question on their test. So we can see we have two variables. Let's say capital T is true-false, and capital M is multiple choice. So we have to be able to write two equations based on the information here in order to solve for both variables. So one thing we know is that there are 20 questions total. So that means the number of multiple choice questions plus the number of true-false questions has to equal 20. And the other thing we know is the point values for each question. So true-false questions are worth 3, multiple choice questions are worth 11, and they have to total to 100 points. So 11 times the number of multiple choice questions plus 3 times the number of true-false has to equal 100. And now we have a system of equations that we can solve. Substitution or elimination will work equally well here. I'm a big fan of elimination though. So let's multiply the top equation by, let's make this 3t term cancel out. So we're going to multiply the top equation by negative 3. So now we have 11m plus 3t equals 100, and negative 3m minus 3t equals negative 60. So when we add the two together, we get 8m equals 40. And divide by 8, m equals 5. And then we just have to substitute this here. So 5 plus t equals 20. Clearly t is 15. So we have 5 multiple choice questions and 15 true false questions. Sounds like an easy test. So yeah, most of these systems word problems you'll be able to set them up in a fairly straightforward manner because they're going to give you 2 variables and then two pieces of information that help you write 2 equations to solve for those variables.